Hello and welcome. This is going to be our lecture video on vector addition. Go ahead, put today's date and the lecture number at the top of your notes, and let's get started. So what is a vector? A vector is just a very fancy type of arrow. Every single part of the arrow has a name. The length of the arrow is called the magnitude. The start of the arrow is called the tail. The pointy part of the arrow is called the head. And this arrow has some sort of direction, often measured in degrees. So let me say that is, pen here, often measured in degrees. But it could also be something like northeast, south, or it could be measured in radians is another way to measure an angle. Or this whole thing could be given in polar coordinates, but we're not going to talk about that too much this year. All right, so when we talk about adding vectors together, this is what we mean. The two vectors, they both have a head, a tail, a magnitude, and a direction. How we're going to add them together is first by drawing the first vector, then by drawing the second vector starting at the end of the first vector. And then after all that's done, we're going to create a new vector that begins at the tail of the first vector and ends at the head of the second vector. So, if I've got vector number 1 looks like this, and vector number 2 looks like this, adding them together would be to draw one and then just attach the next one right to the end of that. And then the resultant is this arrow that combines the two. So how do I find the magnitude of that resultant? So let's imagine that I'm adding together two vectors. So vector 1 will just be an arrow going straight north. We'll say it's going straight north 5 inches. All right, and then I'm going to add to that a vector going straight east. And we'll say this vector is going 7 inches straight east. So it's really nice if these two vectors connect at a right angle, because now we've just constructed a right triangle and we can use the Pythagorean theorem to find this length over here. So the Pythagorean theorem is a squared plus b squared equals c squared. A and B just have to be the legs of the triangle, and C has to be the hypotenuse. You can swap around A and B, but C always has to be opposite from the right angle. It always has to be your longest side. So I'll label these A and B, and then plug them into my equation. 5 squared plus 7 squared equals C squared. And now that C is our only variable, we can solve for it. This is going to become 25 plus 49 equals C squared. Let's see, that's 74 equals c squared. Take the square root of both sides. And I get on my calculator the square root of 74 is 8.6. Now it will have the same unit as these two components here. So it's 8.6 inches. All right. The next thing I'd like you to be able to do is to find the degree measure of your resultant. So first off, we need to know where different degree measurements lie. So if our angle is drawn in standard position, that means it's drawn on a coordinate plane like this. Any resultant that points up and to the right is going to be between 0 and 90 degrees. Up and to the left would be between 90 and 180 degrees. All right, our next marker is at 720 degrees, and if we keep going around, we'll see that 0 is the same as 360. We'll just leave it at 0 for this. So instead of saying north, we could say 90 degrees. Instead of saying east, we could say 0 degrees. South is 270. West is 180. So how do we find the direction of the resultant using those degree measurements? We're going to have to use just a little bit of trigonometry. So let's say we're adding together two vectors that look like this. One takes us maybe 8 miles straight east. The next one takes us 5 miles straight up. Here's our resultant. What is the angle measurement of this resultant? So we don't have to do the Pythagorean theorem. What we do need to do is designate our interior angle here as theta, and then use trigonometry to figure out the measure of theta. So from theta, this 5 over here is our opposite. This 8 right here is our adjacent. All right, opposite always opposite of theta. Adjacent always connects to theta. Simple enough. Opposite and adjacent are connected by tangent, so I can set up the algebraic equation. Tangent of theta equals 5 over 8. And then I get rid of tangent by using the inverse tangent button on my calculator. So the inverse tangent of 5/8 will give us that angle measure theta. Inverse tangent of 5 over 8 gives us 32 degrees. So theta equals 32 degrees. Let's try another one. Here our two vectors are, the first one is heading out at 0 degrees and it has a length of 7, or magnitude of 7. The unit is meters per second, but we're just going to ignore the unit until the very end. The next one's going up at 2 meters per second. So 7 and 2, our resultant would look like this then. Let's figure out the degree measure here and the length of this. So I have to now do both Pythagorean theorem and the trigonometry. 2 squared plus 7 squared equals c squared. 4 plus 49 equals c squared. 53 equals c squared. Take the square root. And I get 7.28. Now I just need to find the degree measurement of this vector. I'll do that by establishing this 2 as my opposite, this 7 is my adjacent, and then doing tangent of theta equals opposite 2 over adjacent 7. Take the inverse tangent of both sides. Make sure you're in the right mode here so that you get an answer in degrees. I like degrees a little bit better than radians. So inverse tangent of 2 over 7 gives me 15.9 degrees. So theta equals 15.9 degrees. Now we can add in that unit. Our final answer is 7.28 meters per second at 15.4 degrees. And that is our resulting vector. It has a magnitude, 7.28, and a direction, 15.4. One thing I just wanted to point out is that when you do that trig, it just gives you the measurement of the interior angle. Here we've got a vector that's going east and a vector that's going south. So when I find that interior angle, I get that it's 45 degrees. We need to know to add that to the 180 to get the measurement of this angle in standard position. So 180 plus the 45 gives us a measurement of 225 degrees. So you should add on your measurement to the nearest cardinal direction. So either the 90, the 180, or the 270 to get the measurement to that actual line and not just the interior angle. All right, let's call that good for this lecture video. I'll embed a few more questions here and have a good rest of your day.